Hello students, in this video we are going to learn motion of a charged particle in a uniform magnetic field. As we know, if a charged particle is moving in a magnetic field with velocity v and magnetic field v and making an angle of theta, then force between them due to magnetic field is v cross q v cross v, and if we write magnitude it will be q v b sine theta. So if the angle when the initial velocity is first case, when the initial velocity is parallel, when initial velocity is parallel to the magnetic field, in that case both velocity and magnetic field, if both are parallel, theta will be 0. So force will be equal to sine 0 is 0. So force will be equal to 0. No force will act on them. Case 2 is when the initial velocity is perpendicular to the magnetic field. So in this case theta will be equal to 90 degree. So force will become maximum QVB sine 90, which is 1 QVB. So we are going to take this case in brief by taking one example. You see, we are going to consider in a region where magnetic field is perpendicular to the plane and inward, and that we are representing by cross. So in this region of space we are assuming magnetic field is perpendicular to the plane and inward, and that we are representing by cross. And suppose we are throwing a charged particle q with initial velocity v, and that is perpendicular to magnetic field. Let us say this is the direction of velocity. So the angle between v and b 90 degree. So force will be qvb, and this force continuously deflects the particle, and the charged particle will move along a circle and perpendicular to the field. So let us draw that diagram. The charged particle will move along a circular path in the magnetic field, and let us say the radius of this circular path is r, and force is going to act, that is qvb, perpendicular to both magnetic field and velocity. So this is the direction of force, and we can say this force, magnetic force, is acting as centripetal force and taking the charged particle along circular path. So let us write some statement here. Charge q is projected with a speed of v in plane of paper, in plane of paper, this velocity or the velocity is perpendicular to the magnetic field B. So force magnitude will be QVB, and this magnetic force is going to provide necessary centripetal force. We have assumed r as the radius of the circular path, so we know centripetal force is equal to magnetic force. It is mv square upon r, and it is qvb. Magnetic force qvb, centripetal force is given by m into v square upon r. So from here we can say v will cancel. So r can be written as, if you cross multiply, mv upon qb. So this is the radius of that particular circular loop. This they will ask you to derive in exam. So we can derive, and time period of revolution of the charge. Time period of revolution. So we know time is equal to distance upon time. So that is circumference upon time equal to circumference upon speed. Distance upon speed will be time. So that is 2 pi r, and speed we know v. And if we want v, so it can be written as qrb upon m. We can put it here. R will cancel, m will go up, 2 pi m upon qb. This is the time period. Frequency of revolution we can also write. So frequency of revolution is equal to reciprocal of time. So qb upon 2 pi into m. This much only in this video. Thank you.